All right, let's do this. Hey everybody, and welcome back to T.Will Tutoring TV, where we instill hope through math. I am your host, Taya, and for today's episode, I wanted to start with calculus. I wanted to go over one of the basic concepts that builds within calculus, talking about continuity and the difference between a function being continuous versus it being discontinuous. So I know these words sound very interesting, so let's go ahead and dive right in. So what does it exactly mean for a function to be continuous? A function is continuous when you can draw your function without picking up your pencil. So that means there's no holes, no breaks, no jumps, none of that. We can draw this function very smoothly without picking up our pencil. Okay, so if we know what it means for a function to be continuous, what does it mean when a function is discontinuous? We're going to go into some examples.
So when we say a function is discontinuous, all we're saying is that there is a disconnect somewhere within our graph, meaning that if I was to draw this graph, right, at some point I would have to pick up my pencil in order to continue drawing it. So there are three types of discontinuities you'll see within calculus. So the first one I want to talk about is called point discontinuity, also known as removable discontinuity. So with this discontinuity, there is a hole within your graph or within your function. So a point has been removed from our function drawn. So an example of what that would look like, so let's say we're at A, right? So I'm going to say we have a horizontal line, but then right at about y equals 3, we see that this is where the point has moved to. So this would be an example of point discontinuity here, because my point has literally been removed from my horizontal line. So the next discontinuity I want to talk about is jump discontinuity. So when we talk about jump discontinuity, that means that we're skipping or we're jumping in order to continue to draw our graph. I like to think of piecewise functions in this scenario. So I'm going to stick with looking around A. So let's say from this point to the left, we're completely defined, but then from A to the right, we notice that we have a horizontal line that occurs. So I would consider this to be jump discontinuity because I've jumped or skipped to another y value in order to continue drawing my graph. So the last discontinuity I want to talk about is infinite discontinuity. So infinite discontinuity deals with asymptotes. Asymptotes are going to be either horizontal or vertical boundaries within your graph that your line or your function will get really close to these boundaries, but they will never touch. So I'm going to say, we'll still look at A. All right. So we're going to have a vertical asymptote at A. But right at y equals 0, we'll also have a horizontal asymptote here. So at y equals 0 and x equals A. All right, so an example of how the graph will be drawn. So you'll see my line will get really close to my boundaries, but I'm never touching I'm never touching. Okay. So this will be an example of infinite discontinuity. So you see, with every single example, I would have to pick up my pencil in order to continue drawing these graphs. This is, in essence, what discontinuity means. So yeah, so always keep in mind, if it's continuous, that means I can draw this graph without picking up my pencil. But if it is discontinuous, I would have to pick up my pencil in order to continue to draw it.
And just like that, we're back. So not too bad, not bad at all. What questions did you all have? Be sure to write them down in the comments down below. I'll be sure to respond to you all there. Before we leave, we're going to go into my next segment that's going to be called Dive Deeper. Okay, this is going to be the segment where I pose a question to you all and you give me responses down in the comment section. This is our community. This is our space where we learn and we grow together. So, question of the day: what is the importance of learning basic concepts first? Okay, I'm not going to just leave you all with a question. I guess I'll answer. Those of you all who don't know, well, of course you don't know. I just introduced myself. I'm new here. For those of you who don't know, I practice yoga. And one of the big things within yoga is learning the basic poses, learning the basic concepts, or like the core concepts within yoga. So your breath to movement, making sure you're inhaling and exhaling, never holding your breath. Your breath to movement is so important. Engaging your core. All of these concepts, they come together and they make the foundation of yoga. As you go into more intricate and more challenging poses, your foundation allows you to be able to build upon your routine, your practice with such ease, in spite of the challenges that come. Math, honestly, it's the same way. Math builds upon itself. Once you understand the basic concepts, then you can build upon it in more complexity. And even though, I'm not gonna lie, it may still be challenging, but because you have those basic concepts, the challenge comes with a slight ease. I know. It's like ease and challenge together. Yes, it can be together. It happens. So I put the question in your hands. Give me your thoughts. What do you think is the importance of learning basic concepts first? I want to know. Until next time, remember, you are capable, you got this, and count yourself in. I'll see you all soon.